So today we're going to work on lesson 4-5. It's called An Average Joe. What's that going to mean, an average Joe? So it says the average dog is a nicer person than the average person. Ooh, sometimes. Are you an average college student? What does that even mean? According to a variety of sources found on the web, the average college student is 20 years old, lives on campus, and works off campus during the school year. She is female, talks to her parents every day, and comes from a family with an annual income between $50,000 and $100,000. She sleeps 6 hours a night, has $2,700 in credit card debt, and will leave college with $21,000 in total debt. Wow. That's amazing that they know that much about all of us humans, isn't it? So if this doesn't sound exactly like anyone you know, don't feel bad. As we will learn in this lesson, the word average is ambiguous. Ambiguous means it's kind of fuzzy. We're not exactly sure what it means. Okay, so down at the bottom it says, our goal in this lesson will be to understand the different measures of average. In casual terms, average means the most typical case or the center of where the values in a data set are distributed. In this lesson, we'll study 4 different ways of measuring average. It'll be the mean, the median, the mode, and mid-range. Let's suppose that an individual, let's just call him George, is about to finish college and step out into the workforce. George finds a small company called Vandelay Industries, which he's considering going to work for. While researching this company, George finds a flyer on which that company advertises that its average employee makes almost $150,000 per year. Sounds pretty good. So this sounds pretty darn good to George. So he accepts an entry-level position at a low salary, betting on quick advancement to that alleged average. Shortly after starting his career, while emptying the recycling bin in the copy room, just one of George's glamorous duties, he stumbles across a list of salaries for all employees at his company. Let's investigate just how true the company's average salary claim is. Says, here's the salary list for Vandelay Industries, which we'll use to study measures of average, which are more technically called measures of central tendency. So be on the lookout for that question on some of the worksheets. We might mention measures of central tendency. So here are a list of the employees: Jerry, Kramer, Newman, George, Elaine, Susan, Tim, Estelle, and Frank. And here are their salaries. And it sure sounds a lot like Seinfeld if you've ever watched it. So the first measure of central tendency that we're going to look at is called the mean. There's a pretty good chance that when you think of average in a math class, what you're thinking of is actually called the mean. The mean, also known as the arithmetic average, is found by adding the values of the data and dividing by the total number of values. Here's a good way to think of the mean. If all the numbers were equal weights, put on a number line. The mean is where the number line would be balanced without tipping in one direction. So it would just be balanced right there. So the Greek letter right here, it's called sigma, is used to represent the sum of a list of numbers. If we use the letter X to represent data values, then this symbol here means to find the sum of all values in a data set. Using this notation, we can write a formula for finding the mean. So the mean is the sum of values in a data set divided by the number of values. So if these are your values, when it says we're going to sum them up and divide by n, we're going to call this X bar. And this would be called the sample mean, X bar. Meaning, if we took all the values in a data set that's from a sample and added them and divided by n, that's what we would get. There's a different symbol for if you have population data, but it's rare that we're ever going to have data from every object that we're trying to study. What we described our population in lesson 4.4. So number 1 says, find the mean salary for the company. Now, I'm going to show you a few things in Desmos today. And here we are. And I want to go to my okay. So here are all of the data. It says find the mean salary for the company. So here is a list of all the data points. And I'll make sure we have them all 58, 65, 20, 52, 51, 53. Yeah, okay. So if we want to find the mean, we can just go down to a line here and you could add them all up by hand if you wanted, but I want to show you. So in case you have a bigger data set or something in ALEKS, you can just type mean and then a parenthesis and you can say X1. And it should give you the average. So that sample mean is equal to $149,777.78. We'll round that to appropriately. Okay. Let me take you back to my paper here. So down at the bottom, it says Newman owns the company and obviously pays himself a handsome salary. If we ignore Newman's salary, what is the new mean? Based on this, do you feel like the mean is a good measure of what the typical employee makes? So remember, this is the mean up here, number one from everyone. And now we're going to go back to StatCrunch and I'm going to just delete out Newman's. And now the new mean X bar is equal to 50,500. Yikes. So if we don't include him, it doesn't look like everybody makes very much money, right? So it says, if we ignore Newman's salary, what is the new mean? We found that. Based on this, do you feel like the mean is a good measure of what the typical employee makes? No. Because Newman's salary makes the average appear large. So average or mean. So could there be something better that we could look at to describe the salaries there for somebody getting higher that isn't Newman, right? So the median, according to the National Organization of Realtors, the mean selling price for existing homes nationally in August 2015 was $271,600. That seems expensive. The median selling price, on the other hand, was $228,700. Since both of these are measures of central tendency, how can they be so far apart? What exactly is the median? In this case, the median tells us that half of all homes sold during that month were priced above $228,700 and half were priced below that amount. In short, the median of a data set is the value in the middle if all values are arranged in order. The median will either be a specific data value in the set or will fall in the middle in between two values. Here's how we'll find a median. Arrange all the salaries at Vandelay Industries in order from smallest to largest. Okay, so we had 20,000. We had 50,000. We had a 51,000. So there's a 20, there's a 50, 51. We have a 52,000. A 53,000, a 54,000. No, this a 55? This should be a 55,000. And then we have 58. 65,000, and then Newman's 944,000. Okay. So it says find the salary that's right in the middle of your ordered list. That's the median salary. How does it compare to the mean? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 data pieces. So I'm going to just kind of find the middle. So these two kind of get pulled off to the side, then these two, then these two, then these two. So it looks like 53,000 is the median. Okay, and it's when we include all of the data points with Newman, then it is much smaller than the mean. Oh, 149, 777, and 78 cents. So number 5 says, if there is an even number of values in a data set, there will be 2 values in the middle, not 1 like in question 4. How do you think you'd find the median in that case? So in that case, we have to take add the 2 in the middle. Have the 2 middle values and divide by 2. So it's essentially taking the average of the 2. Number 6 says, find the median of the salaries at Vanderlei Industries without Newman's. How does it compare to the median of the salaries with Newman's included? Okay, so if we take Newman's away, then the 2 in the middle are going to be 52,000 and 53,000. So the median would be 52,000 plus 53,000 divided by 2, which is going to be 52,500. And that actually is very close to the median with Newman. So Newman doesn't seem to distort the median. Okay, very close. Let me include Newman's. Okay, so this is a lesson check, by the way. So this is 52,500. This is a lesson check for 4-5. What does this tell you about median when there are outliers, sample data values that are very far away from the majority of the values? This is a very key idea, so give it some thought. What does it tell you? What does this tell you about median when there are outliers? The outliers don't affect the median much when there are outliers. Find the median of the salaries at Vanderlei Industries without Newman's if Kramer quits to start his own company. The Peterman Realty Tour. What can you observe? Find the median salaries without Newman's if Kramer quits to start his own company. So we're not going to have Newman or Kramer. So we are not going to have the 6,500 or the 944,000. So both of those are gone. So then we're back to having an odd number again. So it would just be 52,000. What can you observe? Still not affected much at all. think the median is pretty good measure of central tendency to use. Okay, let's look at the third one. So we're on the top of page 451. It says the mid-range is another measure of average. The advantage of the mid-range is that it's very quick and easy to calculate. The disadvantage is that it totally ignores most of the data values. So it's not a particularly reliable measure, but in a pinch, it can give you a rough idea of average. Okay, so you're going to find the smallest and the largest values in the data set and find the mean between them. So you don't really care about anything in the middle. Find the number halfway between the lowest and highest salaries. That's the mid-range. Okay. Let's do including Newman's. So the lowest we said was 20,000 plus Newman's, which is 944,000 divided by 2. The mid-range would be 482,000. And number 10 says, find the mid-range of the salaries excluding Newman's. How does it compare to the mid-range of all salaries? So excluding Newman's, the largest would now be Kramer's, which is 65,000. So it's going to be 20,000 plus 65,000. So the mid-range would be 42,500. When we don't include. So the mid-range is very much affected. Very much affected by outliers. Explain why the mid-range isn't very reliable as a measure of central tendency. Because it's affected by outliers. So just what I said there, that's why you don't want to use it. You're only taking into account the smallest and the largest, and it's definitely swayed by a really large or really small value. Okay, let's flip the page to 452. So the mode. The fourth measure of average is called the mode. The mode is sometimes said to be the most typical case. These data represent the duration in days of the final 20 US Space Shuttle voyages. Which number of days appears most often on the list? That's the mode. So let's just see which one occurs the most. 11 occurs 1, 2. 10 is not 10. 10 only occurs once. It's not 11. 12 is 1, 2, 3, 4, 5, 6, 7. And 13 is 1, 2, 3, 4. 15 is 1, 2, 3, 4, 5, 6. So it looks like the mode is 12. How does the mode compare to the mean? Which do you think describes a typical case best? Kind of hard to describe, how to decide. So the mean of these data is 12.9. So they're very close to each other. In this question, I think the mode is probably better because of the type of data. Because there's not very many different possible outcomes. And so I would think that the mode is probably a better way to describe this particular data. Down below it says a data set can have more than one mode if two or more values are tied for most appearances, or no mode at all if every value appears only once. While modes aren't extremely useful for small data sets with numerical data, we'll begin there to help get an understanding of what the mode is all about. The number of wins in each 16-game season for the Cincinnati Bengals from 1996 to 2018 is listed below. Find the mode. Number of wins that occurred the most. Not 2 and not 3. The mode 4 happens 1, 2, 3, 4 times. 8 happens 1, 2, 3, 4 times. 6 happens 1, 2, 3. 7 happens 1, 2, 3. 11 happens 1, 2. 10 happens 1, 2, 3. So it looks like 4 and 8 both occur 4 times. So we would say this is bimodal because there's 2 modes. And then it says, how does the mode compare to the mean? Discuss again. Include a description of which measure of central tendency you think is more reliable in general and why. You might consider the fact that there might not be a single answer. It could depend on what you want to learn from the measure of average. Yep. So let's just go back to Desmos to put our data in for the number of wins by the Cincinnati Bengals. So I am going to go up here and start a new blank one. And so I'm going to do a table. And I've got 8, 7, 3, 4, 4, 6, 2, oops, 2, 8, oops, it should be 8, 8, 11, 8, 7, 4, 10, 4, 9, 10, 11, 10, 12, 6, 7, and 6. Okay. And then when I go down here and I take the mean of X1, I just put in the column and then it gives me the mean. And the mean says that it's 7.17. Which I would say is a better description of our scenario because the mode only picks up the one that occurs the most or 2. So the mean best describes the center typical of the data. This one. So overall, I would say the mean is probably our best measure of center that we look at, the most reliable because it takes into account all of the data points. Unless, of course, our data has some outliers. We do have to take that, we do have to think about that. So number 16 says, do the employee salaries at Mandalay Industries have a mode? No, because no 2 people have the same exact salary. Okay. The mode is probably most useful when data are classified by groups or categories. In fact, it's the only measure of central tendency that even makes sense when the data values aren't numbers. For the average college student at the beginning of the lesson, I challenge you to find the mean of male and female. And that would be here. This was all about the average student, right? And so that's going back to think about that. 17 says, a survey of the junior class at Fiesta State University shows the following numbers of students majoring in each field. Find the mode. So this would be the category that occurs the most, the major that most students choose, and that would be the business major. Now let's evaluate the average salary claim by Vandelay Industries at the beginning of this lesson. How truthful do you think the claim was? Use the measures of average you found in this lesson to discuss whether or not you think they were being deceptive in any way. I'm not going to say that this question is the main point of the entire lesson, but it is. It for sure is. So I'm basically going to give you two scenarios. When you compare your mean to your median, always put your mean on the left because alphabetically MEAN comes before MED. Okay, so if you compare them, if your mean and your median are pretty close, that is approximately equal. Then we can say our data is symmetric. We did not bring this up in the lesson, but I am because I want you to know this. It's symmetric, and the mean is the best measure of center. Okay, here is the mean. Okay, if go down here, if you compare the mean and it is greater than the median, okay, then we say our data is skewed. And because the arrow is pointing to the right, again, the mean on the left and the median on the right, if this is how your statement is and the mean is greater than the median, then we say our data is skewed right. And the median is the best. Okay. Or if you compare the mean and the median, and your mean is significantly less than the median. Okay, so either of these situations, we're going to choose the median. But on this one, then we say our data is skewed left. And again, the median is the best. Okay, so when we say approximately equal up here, you kind of have to make that decision on what do you think is approximately equal. Okay, and if that's reasonable, then you would say that the data is symmetric and we're going to choose the mean as the best measure of center. If our data is skewed in any way, where the mean is much greater than the median or the mean is much less than the median, then we would use the median as the best measure of center. That wraps up the first part of lesson 4.5. Catch me back for the second part here in a bit.